Good morning, my dear friends. See now let's take up another example in this problem. Okay, I will read it. For the beam shown in figure, find the principal tension at 200 mm from the top at a section 1.2 meter from the left support. See now here he has given a beam, oh sir, no, of a span say now 10 meter, and it is rectangular in section 300 mm by 500 mm. Okay, is its cross sectional this thing now. So what he has asked is now he has asked you to find out the principal tension at 200 mm from the top. In the sense, from the top at 200 mm you come down. Okay, in the sense that your element is now here now, as I have shown. Okay, this is 250, am I right? Now this CGC lies at 250. Okay, and your element lies at 200 mm from the top. Okay, so element is now here. So here you have to find the principal tension, that too at a section XX which lies at a distance of 1.2 meter. That's what he has said. At a section 1.2 meter from the left support. He said a rundown. At this cross section, okay, the element is at a distance of 200 mm from the top. Okay, okay. I hope you understood it. Now I will read the problem now. I will read it now again so that you can easily understand it. Okay. For the beam shown in figure, find the principal tension at 200 mm from the top at a section 1.2 meter from the left support. Assume effective pre-stress in the cable as 600 kilonewton. Okay, he has given the effective pre-stress. Okay, the beam carries a UDL of 27600 Newton per meter in addition to its own weight. In a sense, this is the live load he has given. Okay, in sense now, the density of concrete he says that it is 2400 Newton per meter cube. Okay, so now let us see how it can be now solved. But now area can be now easily calculated. It is 300 mm by 500 mm. Okay, it will give me the area. Moment of inertia can also be calculated. It is BD cube by 12. Okay, and now WD can be now easily calculated, and in sense it is the dead load. Okay, it is 0.3 into 0.5 into 1 meter along the span. Am I right now? Along the span. Okay, that will give me the volume. 0.3 into 0.5 into 1, it will give me the volume into density of concrete. Okay, WD is so much. Also, but now he has given the live load. Live load on the beam is now he says that the beam carries a UDL of 27600 Newton per meter. Okay, so the live load is 27600. So if I add these two, I will get the total load W. Am I right now? So once I know the total load. Okay, total load which is acting on the beam as UDL. Am I right now? This is the UDL which is now acting on the beam, including the self weight. It is self weight plus live load. So now, since I know the UDL acting on the beam here, but now I think I can easily calculate RA and RB, reactions RA and RB. Okay, so RA and RB can be now easily calculated. It is given as WL by 2. Am I right? W I know, L I know, span of the beam is 10 meter divided by 2. It will give me so much. Okay, so now, but now once I know RA and I know that the here UDL intensity is now 31200, I think now I can easily calculate how much is the shear force at XX, because he has asked you to calculate the principal tensile stress at a section XX which lies at a distance of 1.2 meter. Am I right now? So now I want to find out how much is the shear force at XX. Okay, see now. So now shear force at XX which lies at 1.2 meter from left support can be calculated as, Baba, is the reaction RA. Okay, RA minus this much load. This load is, it is 31200. 31200 is the intensity into 1.2 will give me the total load. Okay, this RA minus this load, it will give me the shear force at this section XX. Am I right? So now the same thing I've written is the reaction RA minus 31200 into 1.2. So it will give me shear force at section XX as so much. Okay, this is one thing now. So now, next part is now, okay, see now. Similarly, I want to calculate now the bending moment at xx. Okay, bending moment at xx also I want to now calculate. But now, since you know everything, I think you can easily calculate this thing now. It is reaction into 1.2. Okay, it is the reaction RA into lever arm 1.2 minus the UDL is 31200 into 1.2 will give me the total load. Total load into lever arm 1.2 by 2. Okay, it will give me the bending moment at xx. Okay, so bending moment and shear force at xx I have calculated. Okay, also, but now you know that for the parabolic cable, okay, first I will take up this one now. See now, for the parabolic cable, you can write this thing one out. Y is equal to 4h L square into x into L minus x. I think this is the equation of the parabola with one end as origin. I think in the last problem I have said you. Okay. Though, so from this equation, I can write dy by dx or tan alpha or sin alpha. Okay. If I take the derivative of this, it will give me this 4h by L square into L minus 2x. Am I right? Just check once. Okay. Okay. So but now dy by dx means it is slope. It is tan alpha. Or since the slope is small, I can call it as sin alpha. Am I right now? So but now here, this in this equation, see now, h is it is the total dip. Okay. See now, total dip is, please see here now. See now, in sense the cable is laid parabolic like this, as you know. Baba, from CGC, it has got a dip of 120 mm. Am I right now? And this cable has gone upward from CGC by 20 mm. That is what the problem states. So now 120 mm plus 20 mm. Total dip is 140 mm. Am I right now? Total dip is 140 mm. This is the origin. This is the origin. Okay. So from the origin, the total dip is 140 mm. Is it right? So now total dip H can be written as 140 mm. Am I right now? 140 mm is your total dip H. Am I right now? And span is 10 meter, as you know, and X is 1.2 meter from the origin. So now if I put all these values now here, it will give me the value of tan alpha or sin alpha. Am I right now? So now it works out to be 0.442 radians. Similarly, I want to calculate y also now. Okay, y is the dip. Now I want to calculate this dip at x is equal to 1.2 meter. Baba, 4 is 4. H, just now you came to know that it is 0.14 or 140 mm. L is span 10 square. Okay, and x is at 1.2 it is now. Okay, L is 10 and x is again 1.2. In a sense, what is y at a section 1.2 meter from the end of the support? So it is now 59.14 mm. In a sense, y means it is this much now. See now, it is this much. In a sense, at this cross section, how much is the dip of the cable here? In a sense, this much I have calculated. Okay, this much has worked out to be, just now you have seen, it is how much now? It is 59.14. Okay, see now, this total dip is 59.14. Okay, out of that, 20 mm is from here to here, because it is 20 mm, 20 mm from here to here. So now at section XX, how much is the eccentricity? Eccentricity can be now easily calculated. Eccentricity is from CGC to CGS. Okay, so it is 59.14 minus 20 mm. It will give me the eccentricity. Am I right? So now the same thing I have done here now. Eccentricity works out to be, here you can see eccentricity at x-axis is 59.14 minus 20. It will give me 39.14 mm. Am I right? So it is the eccentricity. So but now let us consider the given section at x-axis and the element is at 200 mm below the top, okay, or 50 mm above the CGC. So now I want to calculate now VC. VC is given by V minus P sine alpha. Okay, in essence, VC is VC at section XX. Am I right now? So I'm interested in section XX. So if at all I want to calculate VC at XX, it is V at XX and P sine alpha at XX. Am I right? So shear force at XX we have already calculated. It is so much. And P sine alpha P is so much. Okay. Sine alpha just now you have calculated. Okay, sir. Now at XX it is 0.042. Am I right now? It is you have calculated here now. Tan alpha or sin alpha. Am I right now? Its value works out to be 0.042. Am I right now? So it is 0.042. So shear force in the concrete at section XX is 93360 newtons. Okay, this is your this thing now. So now, Baba, your moment of inertia is so much. Your breadth B is so much. Your AY bar, I think you can easily calculate. Okay, AY bar. So now tau C can be calculated. Tau C at XX. It is VC AY bar divided by IB. Baba, almost all the values I know it. Oh, so you can easily calculate tau C. Okay, and now, Baba, now bending stress due to pre-stress is sigma x I want. Baba, it is F by A plus or minus FEY by I plus or minus MD plus MLY by I. Am I right now? So F I know, okay. MD plus ML also you know, okay. It is so much, and Y is it is 50 mm. It is above CGC plus, okay, 50 mm. So eccentricity I know, okay. We have calculated. So now fill up here all the values now. So you will get the value of sigma x. Sigma x you came to know. Baba, sigma y is 0 because your vertical processing is absent. Okay. Once you know sigma x value, sigma y value, and tau c value. Okay. So I think you can easily calculate the principal tensile stress FCT can be calculated by the equation sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 plus tau c square under root. So now fill all the values, you will get this answer. Okay. Thank you very much.